Hello grade 11s, welcome to your first flipped lesson. Today we're going to look at graphical solutions of quadratic equations. Okay, a quadratic equation is an equation, this is on page 147 if you want to follow along. It is an equation in which one of the terms is squared and no other term is raised to a higher power. So we're really looking for this squared term right there. And here's some examples. Roots are solutions to a quadratic equation. They make them true. They correspond to the x-intercepts, and they're also called zeros. They're the values of x that make y equal 0. And the awesome thing about this is we can always check our solutions by substituting into the original equation. So you can know with certainty if you've done this correct. Okay, so right here we have x squared minus 5x plus 6 equals 0, and they have graphed it. So this is a nice graph right there. Okay, and they saw there's two spots where it intersects the x-axis, and that is at 2 and at 3. So if we take the value 2 and we sub it back into that original equation, we get 2 squared minus 5 times 2 plus 6. We subbed it in there. Well, that's 4 minus 10 plus 6 is 0. Yes, we did something right. We do the same thing with the other x-intercept, the other 0, the other solution. And we say 3 squared minus 5 times 3 plus 6, subbing it in here. Well, that's 9 minus 15 plus 6 is also 0. Okay, the graphs of quadratic functions can have either 0, 1, or 2 x-intercepts. So in other words, it can have 2, 1, or 0 zeros. It can have 2, 1, or 0 solutions. Okay? So first of all, if it's above the x-axis, well, it doesn't even cross ever. So it has no x-intercepts, no zeros, no solutions, no roots, rather, and no solutions. Okay? We can have where it touches just once. We have one x-intercept, 1 0, and 1 root. And that number real has to do with real numbers and imaginary numbers, because in this case, there's actually an imaginary root, but you don't need to know that just yet. Okay, in this case, it intersects twice, so that means it has 2 x-intercepts, it has 2 zeros, 2 roots, 2 solutions. Okay, so we need to graph, and then we need to figure out solutions. So our next question here says, determine the roots of each equation by graphing the function. Use either paper and pencil or technology. And I'm going to start with this one right here, and I'm going to use technology. X squared plus 6x plus 3. The technology I like to use is a graphing calculator, and I found a really nice online one that I think I've shown you before, and it's called the Desmos Graphing Calculator. So I just Googled Desmos Graphing Calculator. If you want the link, it's www.desmos.com/calculator. And while you're at the computer, I would take a couple seconds and try this out. Okay, so what I did is I did y equals x squared plus 6x plus 3. It's all regular typing. The only tricky part is getting that squared. To get it to squared, I had to press this a to the power of b button. Okay, that's the only tricky part. Okay, now what I want to do is I see that, look, there are 2 x-intercepts right there, and I want to know exactly what those are. I forget how to trace, so I go to help, and it says, how do I trace a graph? Click draw on any graph to trace. As you move your mouse, it'll trace the curve. Okay, so I'm going to click here. Oh, look, I'm tracing the curve. I want this exact point. There it is. Negative 5.4 is how I'd round that one. And I also want to know what it is over here. I'm clicking and dragging. Negative 0.6 is what I would say that is. So those are my solutions to this beautiful quadratic equation. Okay, I'm going to show you how to do a pencil and paper in case you want to do this pencil and paper. So first of all, we have to make it look like this first one. We have to bring everything over to that side. So we get, let's see if my pencil works, negative x squared minus 2x minus 1 is equal to 0. What I'm going to do is I'm going to set up a table of values to do my graphing. When I put in an x, what gets spit out? I'm going to start with negative 4. And let's start our beautiful graph right here. What a beautiful graph. Okay, when I put in negative 4 squared is 16, but it's negative 16. Okay, minus 2 times negative 4, well, that's negative 2 times negative 4 is positive 8. minus 1. So I get minus 17 plus 8. Well, that is negative 9. Okay, we're going to do the same thing. We're going to split in negative 3. Well, negative 3 squared is 9, but we have that negative there. So it's negative 9 minus 2 times negative 3. So that's just like adding 6 minus 1 equals 0. So negative 9 minus 1 is negative 10 plus 6 is negative 4. Okay, I'm going to skip ahead. I'm going to go to negative 1, and this time I'll put it in. So I have negative 1 all squared. There's a negative in front. Minus 2 times negative 1 minus 1 equals 0. Well, negative 1 squared is 1. Negative times that is just negative 1. And then I have minus 2 times negative 1 is positive 2 minus 1 equals 0. Well, check this out. I have negative 1 plus 2 minus 1. That's just 0. For symmetry, let's do this other side. Let's go 0. Sorry. Yeah, let's just try 0. 0 is the easiest one to do. It's my favorite point. Okay, so I have 0 squared minus 2 times 0. All of that just becomes 0, and I'm just left with negative 1. And let's do one more point. Let's do 2. Okay, and sometimes you only have to do a couple of these to see the pattern. So negative 2 squared, that 2 in the brackets, minus 2 times 2 minus 1 is equal to 0. Well, this is 4, but it's negative in front of it, so negative 4 minus 1 is equal to 0. Negative 4 minus 4 is negative 8. Minus 1 is negative 9. Okay, let's plot these points. When x equals negative 4, 1, 2, 3, 4, we get negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, right there. I guess you guys can't see me doing what I'm doing. At negative 3, it's negative 4. At negative 1, we've got 0. At 0, we have negative 1. And at 2, we have negative 9. So I didn't do all the points, but actually each of these points are mirrored. If I would have put them all, and I have a beautiful parabola that looks something like that. So how many x-intercepts does this have? Just one right there. It just has one solution. And that solution is negative 1. Okay? That is the root. That's the x-intercept, the solution. All those things mean the same thing. Okay, next up we have the profit of a particular company makes from selling its product is modeled by P of n equals negative 0.1 n squared plus 100n minus 2100, where n is the number of products sold each month. Graph this and explain why it's reasonable. Okay, I graphed this here. Now this one would be a little tough to do on a regular graphing calculator. It's going to be a lot of zooming. But here I have it graphed. And the question it asks, it says, explain why it's reasonable to model it. So it's saying profit is equal to a function in terms of the number sold. So why does that make sense? So on this side, we have our profit. Over here is our profit. Oh, it's not letting me do what I want to do there. I want to write, but it's not letting me write. There we go. Profit. Nope, still doesn't want to let me write. Maybe now it'll let me write. Okay, there we go. Profit is on this side. Nope, won't let me write that. My smartboard's unhappy with me. Anyways, we have profit going up by the 500s, and we have the number sold. Okay? I'm going to pause and just snip this because I don't like what it's doing here. Oh, it's going to slowly write what I wrote 3 minutes ago. Okay, sorry about that. So here we have our quadratic equation. It says, why does this make sense to be modeled? So over here we have our profit. And over here along this side, we have our number of units. Okay, so when I make 0 units, you can imagine this graph keeps going, I lose money. That makes sense. If I have a facility and I have people working, I don't make anything, I'm not making any money. But as I increase my number of units, look, right here I start making money. I keep making money. When I make this many units, like 360 units, it seems like I make $2,000. I keep going up until at some point something happens right here, and then I start to lose money again. So that means that there comes a point where I can only make so many units, and then I need to start hiring more people, or I'm in a higher tax bracket, and eventually I start losing money. Sometimes when companies get too big, they do lose money. Not good companies, but anyways. So this does make sense to be modeled. Next up it says, a business hits a break-even point when its profits are 0. At this point, the business neither makes nor loses money. Determining how many sales the company needs to reach this break-even point. So where it no longer makes money nor loses money, and there's actually 2 of those points. It's at 300 and at 700. Okay? Determine how many sales the company needs to reach this point, either 300 or 700 sales. What should the business owner conclude from the solution to this quadratic equation? Well, they should conclude that they need to make more than 300, but they also want to make less than 700 units. That from that solution, they know they need to make somewhere in between. Well, and from this graph too, they know that they could maximize their profits right here by making 500. They can make a maximum of $4,000. Okay? So we're graphing. We're always looking at those x-intercepts to find our solution. The other thing they could say, if they made more than 700 units, they're going to start losing money. That's something kind of important. Okay, so that's all the concepts you need for today.